Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thanks for joining us today. I'm your host, Henry Regis. Joining me on our program today is CoCoRaHS founder and director, Nolan Duskin. Behind the scenes running the technical side of our program is Zach Schwalbe. We're coming to you live from 5,200 feet at the Colorado Climate Center here at Colorado State University in sunny Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we'll be recording it for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Well, today's webinar, we'll take a look at waterspouts. Have you ever seen one? We're excited to have with us today Joe Golden. Joe is a meteorologist whose career spanned 42 years of federal service. The National Hurricane Center, NOAA's Earth Systems Research Lab, and the National Weather Service are some of the organizations that Joe has been part of. He is an elected fellow of the American Meteorological Society and has chaired many committees for that organization. Today, Joe is the head of Golden Research and Consulting, and one of the fun parts of his job, he tells me, is that he has had the opportunity to give talks on waterspouts very much like the one you're going to hear today to passengers aboard cruise ships. Wow, that's pretty cool. Well, Joe, welcome. It's great to have you with us today. And I got a question for you. If you could take a minute or two and just tell us a little bit about how you became interested in waterspouts and when was the first time you saw one?
It was a pure case of serendipity. I was on a flight in 1967 in a light aircraft that was piloted by my good friend who actually lives in Denver today, Littleton, Bill Woodley, and a group of us in the plane, a total of 4 graduate students that were all working for the Hurricane Center. We're on our way back flying with Bill from Key West, and we accidentally encountered a cumulus cloud line and saw a whole series of waterspouts.
Wow, that's exciting. That's neat. Well, we're going to let you start your broadcast or your presentation. Zach, if you pass the controls on to him, and you should see that in a second, Joe, to pull that up on your screen.
Okay. All right. Let's see if we can get rid of some of this. Okay. Going to be talking about waterspouts. They're part of the family of convective vortices in the atmosphere, the smallest of which are dust devils, which occur in Arizona and other desert locations. Waterspouts are the next to the larger size convective vortices that extend to tornadoes, and finally the largest being hurricanes.
Joe, I don't think we're seeing your screen yet. Zach?
Yep, I've passed control over, so you should be able to see it now. Or you should be, Joe, on the GoToMeeting control panel, just hit the play button on the right side.
Oh boy, it's not on my screen.
Okay, hang on one second.
I did push play and it didn't. Okay.
Oh, I'm getting it on my screen, Zach.
All right, Joe, you should see a box that popped up. Just hit show my screen. There we go.
Yeah. All right.
Take it away.
So this photograph was taken from the top of St. Thomas in the Caribbean, which I'm sure many of you have been to on a cruise ship or on extended vacation. This is a rare photograph in the sense that it was taken from the very top of St. Thomas, looking to the northeast. And in light of recent events in the Nebraska area the last few days, where we had this supposedly very rare twin tornadoes at Pilger, Nebraska, one of the major things I hope you get out of this talk today is that waterspout families are quite common. This is a beautiful case of a waterspout family, the largest of which you see here with a spray vortex and a spiral pattern. Second waterspout here with a dark spot, third waterspout here, and finally a fourth waterspout. So there are 4 waterspouts in this photograph. And in my field experiments in the Florida Keys, I've seen as many as 9 waterspouts over a period of 90 minutes from the same cloud line. So let's define waterspouts. This is from the Glossary of Meteorology, which I contributed the definition to. In general, you can think of a waterspout as any tornado over a body of water, but in its most common form, you best think of it as a non-supercell tornado over water. Although I'm going to show you some examples, a few examples of supercell waterspouts. Generally, they consist of an intense columnar vortex, usually containing the funnel cloud, but not always, that occurs over any body of water and is connected to a cumuliform cloud. And I'll have much more to say about the life cycle. Generally, waterspouts last 5 to 10 minutes, but the bigger ones, the large ones, can last up to half an hour or more. Waterspouts occur in diverse locations all over the world. This is in the Bristol Channel, just off the coast of South Wales in January of 2004. And you can see it was approaching the coast. I think it weakened as it came on shore, as they usually do. This is the first waterspout that I ever saw, which was one of a family. This was the largest of a family of about 6 waterspouts that developed in a cloud line just to the south of Lower Matecumbe Key, which is in the lower Middle Keys, east of Key West. And was able to get some high-resolution Super 8 movies on this waterspout and did some calculations of the wind speeds in the spray vortex that you see there. Same waterspout we discovered when we went back to Matecumbe Key. There were eyewitnesses who watched it actually hit the island. And this is the first eyewitness photograph showing what happens to a waterspout when it moves on shore. The visible funnel becomes contorted, may have turbulent oscillations on the edge of the funnel, but it can still do damage, as it did. It lifted a Cadillac off the ground as it crossed the island, and then you see that same waterspout as it reformed in the Florida Bay just north of Matecumbe Key. So I'm going to give you some true-false questions. I think you may have seen these, but I'm going to give you the answers as we go along to test what you may already know or what some misconceptions sometimes exist on waterspouts. The strongest waterspout is weaker than the weakest tornado. True or false? Waterspouts and tornadoes are essentially the same. True or false? The underlying surface, the lower boundary, meaning land versus water, is not important. True or false? Waterspouts are unpredictable, whereas tornadoes may be. That's especially relevant in light of events this week in the high plains. Waterspouts are too small to be simulated or forecast by numerical weather prediction, computer models. True or false? About 10%, 1 out of 10, of both tornadoes and waterspouts are anticyclonic. True or false? Tornadoes can be scientifically intercepted, but waterspouts cannot. True or false? Well, the answer to the first one, that's false. The strongest waterspout actually is right up there with some EF2 and even EF3 tornadoes. And if they come ashore, they'll produce damage. Tornadoes and waterspouts are essentially the same. That's true. The underlying surface is not important. That's also true. What's important is the environment. It's the mesoscale environment of the parent cloud systems for both tornadoes and waterspouts that ultimately determine the intensity of the vortex that forms. Waterspouts are unpredictable, whereas tornadoes may be. No, waterspouts are very predictable, although in deference to my colleagues at the Key West Weather Service, I think who are online now, it's a really tough thing to forecast waterspouts. We have a very good idea of the kinds of days that are favorable for them, and I'll tell you more about that. But then there's a new study that my colleagues Andy Devanis and his colleagues there at Key West Weather Service have completed, which I think will aid in our ability to predict waterspouts by looking at the sounding information. Waterspouts are too small to be simulated by computer models. That's false. Dr. Bruce Lee did a very clever study of numerical modeling on non-supercell tornadoes at the University of Illinois for his PhD, and his simulations closely approximate what I'm going to be showing you in waterspout clouds that develop waterspouts. About 1 out of 10 of both tornadoes and waterspouts are anticyclonic. That's true. Roger Wakimoto has also shown that there can be some very destructive anticyclonic tornadoes, and he's documented that. Finally, tornadoes can be scientifically intercepted, but waterspouts cannot. If you just get one or two things out of this talk, I hope you'll see that, in fact, the lower Florida Keys are the waterspout capital of the world, and you can intercept waterspouts there if you're careful. The largest waterspouts occasionally produce damage in populated areas. This is one that got me really interested in the problem after the accidental interception of the Matecumbe Key waterspouts just a year before this. This is at Miami's Dinner Key Marina, and you see, looking west of the marina, this very large funnel was about to touch down, and it tore through the marina and lifted this 2-ton houseboat here out of the water, carried it down the pier, and impaled it on this 8-foot wooden piling. Luckily, there wasn't anybody on board, or surely there would have been some really terrible injuries. And they get these even to this day. They get these larger tornadic waterspouts in a number of places in South Florida. And I should hasten to mention at this point that while the Florida Keys are the world's capital in terms of numbers of waterspouts, in our country, Tampa Bay is the lead in the number of destructive large waterspouts every summer. This is a graph of the wind speeds in the spray vortex, and I'm going to show you some examples of the spray vortex in a moment. But these calculations of wind speed as a function of radius in meters per second, and versus wind speeds. I'm sorry, radius in meters versus the wind speeds that you see there in meters per second. And the circular data is for the Matecumbe case that I showed you the slide of just a moment ago. And then the triangle data is of a very intense anticyclonic waterspout that we documented in my program, in my field program during 1969. And that anticyclonic case here, peak wind speeds were about approach to 90 meters per second at a radius of less than 10 meters out from the center of the vortex. Again, these were made by photogrammetric analysis of the movies of the two cases. And the curves show that in both cases the waterspouts approach a Rankine combined vortex, such that the peak winds are very tight. The vortex is very tight, close to the center. And I hope one of the things you get out of this is that these can be very dangerous for both aircraft and for boats of all sizes that happen to get too close. So what do you look for if you're out flying or if you're in a boat? What should you look for in anticipating waterspout development? The key thing, and one of the reasons the Keys is the world's capital, is the frequent development of lines of towering cumulus or cumulus congestus clouds that you see here. This is from the cockpit of a Cessna. And as you approach, typically you'll see a very dark rain-free base and very hard towers that are rapidly building. That's the key thing, is that the updrafts in these cloud lines are quite strong. The average cloud tops in the lines that are just about to produce waterspouts are only about 15 to 17,000 feet. So these are generally warm clouds. These are generally clouds that at the time the waterspouts are forming are not reaching the freezing level, really. Another thing that aids in waterspout development that we looked at is that occasionally, or rather often in the summer, the Keys will experience a passage of weak tropical waves or waves in the easterlies, such as the one you see here. This is the surface analysis. And you see a wave in the morning here that's approaching South Florida. And during 12 hours later, it's past the Keys, and it's during days like this that you get enhancement of low-level surface convergence, and at least on a mesoscale, you get enhanced cyclonic vorticity in this region. And we think that's why some days appear to be particularly active waterspout days. So after my 1969 field experiment, we did some other work to try to get some more quantitative measurements in waterspouts. And so in the 70s, I first worked with a group from Purdue University, and we used a Rube Goldberg approach, which I'm going to tell you about, which is sort of a trial and error method. to see if, in fact, we could get useful data. It turned out it didn't work, as many Rube Goldberg approaches don't, but we learned a lot. And so we went back, and then I developed a collaboration with my good friend and colleague there at Colorado State, Dr. Peter Sinclair. And this slide is wrong. Actually, I think he has a T-28. And so this T-28, and I'll show you more later, is a very rugged acrobatic aircraft, and he had a gust probe on it. So after careful thought, we decided, the two of us, that it would be safe to try direct penetrations with the T-28. We did that. And then later on, with the NOAA labs here in Boulder, where I was working, developed collaborations with the Wave Propagation Laboratory, which is now the Physical Sciences Division. And they have some very clever scientists there that had airborne Doppler LiDAR that we mounted in the back seat of a Cessna aircraft and got some useful measurements there. And I've already mentioned to you there are some 3D cloud models, and they're much better today, that are fully capable of simulating waterspout development and tornado development in clouds. So this is a summary, a plot, if you will, from my one-year 1969 field program. And the first thing this shows is here's Key West, and Big Pine Key is up here, and Marathon is on the far right. So I think from Key West to Marathon it's about 35 nautical miles, and each one of these range marks is 5 nautical miles. Each one of the dots, each one of these black dots that you see, is a different waterspout that we documented just from the aircraft. And there are 100 events there, 100 waterspouts. And on one afternoon in this location, out towards the Marquesas Keys and out towards Fort Jefferson, this is a series of 9 waterspouts that I documented over an hour and a half. So, point being, while there may be some question about how often twin tornadoes occur, there's no question that waterspout families are rather common, not only in the Keys but in other locations, and I'm going to show you an example of Lake Michigan in a little while of multiple waterspout developments. So this is our Rube Goldberg effort with Purdue University, and this is a Cessna, had a trailing wire, a 300-foot trailing wire, electrical wire, and the probe is right there. And this is the probe. Had several instruments packed in it for measuring temperature, pressure, humidity. One of the things you can't always anticipate in new experiments like this, where there's almost nothing that's been done before on an atmospheric vortex like this, is, you know, what's going to happen when the probe actually hits the funnel. It took several tries, but the pilot was able to execute a tricky turning maneuver as we passed by waterspout funnels. And he got the probe to swing into the funnel like this. And when that happened, when we actually got it to go through the funnel, surprise, surprise, there was an up and down, rapid up and down whiplash as it encountered this helically upward vertical velocity. And so that contaminated the pressure measurements. Couldn't trust the pressure measurements, but we did get some useful data, and we learned a lot. This is Sinclair's aircraft. Again, it's, I think, a T-28. This is the gust probe that you see here, and this aircraft is armored. They've flown aircraft like this. South Dakota School of Mines has flown aircraft just like this one, maybe the same plane actually, into hailstorms. So they're armored, they're very rugged, they're acrobatic. It's the only kind of aircraft I would ever fly into waterspouts, and I emphasize that all of our penetrations were done just below cloud base, in the part of the vortex that's weaker, relatively weaker than the surface, than the near surface waterspouts, which, as you'll see, as I've already indicated, have wind speeds of 80 to 90 meters per second in the spray. So it shows that there's some asymmetries in the horizontal velocities through this anticyclonic waterspout that we penetrated. It shows that the core pressure dropped here about 8 or 10 millibars, and very strong vertical velocities surrounding the funnel, and indications of a warm core vortex. So this is a summary of the work with Sinclair and our penetration through waterspouts. Rising motion, again, just below cloud base on the edges of the funnel. reach 5 to 10 meters per second. There's a horizontal circular flow that's broader in weaker waterspouts, and it's more concentrated in the more intense cases. And that was consistent with my photogrammetric measurements as well. And a warm core vortex and a pressure deficit of 1 to 10 millibars, again, just below cloud base. We're sure that that pressure drop is much greater near the surface in the spray vortex. In the intense cases, it's probably approaching 100 millibars, which, by the way, is that's the record measurement so far in tornadoes and pressure deficits. It's of the order of 100 millibars. That was measured by my late friend and colleague, Tim Samaras, using one of his probes in a tornado in Nebraska a few years ago. Now, the Doppler LiDAR is shown here. You can think of a LiDAR as a pencil beam, like a laser beam, and it's measuring velocities that are transverse to the beam by sensing motions of the particles in the funnel or in the spray. In our case, it was just by looking at the funnel. And we actually were able to measure the velocities in a double-walled waterspout, and I'll show you pictures of one coming up. But I'm not going to go into details. This is radius here. This is the power of return in the signal to the LiDAR, line of sight, the velocity components. And basically it shows that in the double-walled funnel, there is a double peak of velocity. That's what these envelopes show, these spectral envelopes show here. So this was sort of the first confirmation of what I had theorized, namely that these rare double-walled waterspouts actually have a double peak in the velocity. So I'm going to show you some examples of the life cycle of a waterspout. This was the subject of my doctoral dissertation at Florida State. And this has been observed now many, many times. And there are very close ties to what storm chasers are seeing this week with tornado development. The first stage in a waterspout is a dark spot. And you see one here. This is a very large one. They may or may not have a funnel initially. And they occur in multiples. Very often you see multiple dark spots. You can only see these from an aircraft, either helicopter or some other kind of aircraft. It's, I would say, not completely impossible, but extremely difficult to observe this from a boat. This is a close-up that you see here. So a dark spot is this circular light-colored disk surrounded by a much darker patch. Do we understand what causes this different reflectivity or coloration? No. You really need to get measurements with some kind of a laser wave measurement device, I think, to really understand what's going on. We don't fully understand what causes the appearance of the dark spot that we see to this day. Sometimes over the area just west of Key West, where in fact at low tide you could walk out here. The fishing there is incredible. I've heard all kinds of reports. The famous treasure from the ship the Etosha, the sunken ship the Etosha that was Mel Fisher found, is somewhere to the west and northwest of Key West in this shallow water, and I've flown over it many, many times. There is a pair of dark spots here on the right. One here, another one here, which is just now beginning to develop, go into the second stage or spray ring stage. They're both moving from right to left. This one now has a spray ring, and it was this same dark spot that you see there. And again, now this one is moving up to the top of the picture. I decided I better try to learn more about this dark spot stage. And so with the help of some friends in the Navy base there at Boca Chica, just to the east of Key West, they gave me some of the marine smoke flares that the jet pilots use when they have to ditch their planes. And after many unsuccessful attempts at bombing a dark spot, namely dropping these smoke flares, I finally got one and managed to position it just ahead of a dark spot that was moving along very slowly, and the dark spot intercepted the flare. And that's what you see here. It began to entrain the smoke. And as it did so, we could actually see the smoke circulating around the edge of the dark spot and also circulating upward until it formed a cup shape of smoke. And so this is the model of a dark spot stage. No spray here. All of this would have normally been invisible except for the patch that you see at the bottom of the figure here. And this is what you're able to see, and the inference you're able to make about the flow features in the dark spot by tracking the smoke plume. Generally, dark spots are either quasi-stationary or they drift very slowly. And I have no doubt that many boaters in the Keys have accidentally, without knowing, gone through dark spots and wondered why the wind shifted. Next stage in the life cycle, second stage, is when the spiral pattern develops. This doesn't always happen in every waterspout case, but it often does. And this is the development of a spiral around the dark spot that you see here. A little bit later, the banding wraps around. And this is long before the environmental movement, or when it was just starting. When I was first studying waterspouts, I kept thinking that most of these features on the water were somehow due to oil pollution. I mean, I really didn't understand what was going on. But nature has a way, you know, after you see this again and again and again, you say, no, this is somehow caused by the interaction of the boundary layer flow with the sea surface. And again, I admit, straight off, that we don't understand what causes either the structure of the dark spot or the banding. We really need measurements to both from instrumented boats as well as aircraft flying at low levels with high-resolution laser measurement devices. So that's a schematic model of the spiral pattern stage. I'm now going to go on. Third stage is a spray ring will develop around the periphery of the dark spot. And that's happened right here. And now you can see the spiral pattern has developed. This was one of the largest cases we had in 1969, just 15 miles north of Key West. Here's the spray ring. And then as the spray ring develops, spray circulates in a helical fashion. It can be carried upward hundreds of feet. Which, by the way, if you read some of the old books that describe waterspout encounters at sea, you often hear about heavy showers, heavy saline showers that fall on a ship as it accidentally intercepts a waterspout. That's explained by what you see here. Again, the spray ring stage, which again your attention is focused right here. And the visible funnel is continuing to lengthen, but in many cases the funnel never reaches the surface. It only extends about halfway down. The mature stage is very dangerous for any ship or aircraft that gets too close. And when you get the mature stage, the spray vortex reaches its maximum size and intensity, and in the larger cases you can have an eye right in the middle, as you see there. In this case, the waterspout was moving, as they usually do, away from the neighboring shower, which was just to the east of the waterspout in the background here. Here's another view looking to the northwest. Waterspout is moving from lower right to upper left. And this is one of these double-walled cases, which you see the outer wall developing here, and in the same waterspout now, the double wall extends 2/3 of the way down to the surface. And there you see it. This is the best case out of 100 cases that I looked at, and it was the cornerstone of my dissertation. Confusing picture here. I don't have time to go into it, but this waterspout was moving. Here's the wake. It was moving in this direction, and it's essentially wrapped. The cyclonic flow is defined by the outer edge of the spiral, but around the edge, outside edge of that spiral is anticyclonic flow. The waterspout is embedded in anticyclonic outflow. And we have some evidence that that also occurs with tornadoes, and I've published on this. And it accounts for the fact that some chasers, even relatively close to some tornadoes, don't always experience inflow into the tornado. The other thing we see from aircraft when you get close is that the funnel changes appearance from a laminar type of condensation funnel. When you get much closer, it turns out that no, in fact, it's a very thin shell of condensation, hollow, and outside that shell is a very turbulent region of cloud matter, which if you are foolish enough to get too close with a light aircraft, you could be in serious trouble because of that turbulence. When you closely monitor it for several seconds, the flow in the mean is upward very strongly, but it's extremely turbulent in these thicker walls of the funnel. And again, this is the conceptual model of a mature waterspout. When the decay stage begins, the waterspout is being intercepted by a neighboring gust front or density surge line. And when that happens, the funnel becomes contorted, highly tilted, and the spray vortex begins to weaken, but it can still be dangerous. It can still be dangerous in the decay stage. In some cases, we see even the development of a rotor cloud from time-lapse that we were taking on the roof of the Key West Weather Service office. And this is the decay stage, and you sometimes also see the funnel has contusions on it, and that may go up or down. And another interesting thing, which also happens with hurricanes, by the way, is in the decay stage of some waterspouts, they execute trochoidal loops, which can be very dangerous to boats. In other words, this waterspout initially is traveling in that direction, and then it begins to turn and loop and turn upon itself, and the weakening spray vortex is here, and you see these waves that are generated to the right of the direction of motion. And these waves can also be dangerous to small craft that get too close to waterspouts. And I'm emphasizing the danger to boats because I'm going to show you some slides at the end of my talk here which add to my fear that people, even in this modern era of high technology and good warnings, improving warnings from the National Weather Service, people are still putting themselves at risk. How do you protect them, and how do you protect them and issue warnings if they won't respond to those warnings? We also found that the older radars were nearly useless in terms of trying to detect waterspouts. And even in the NexRad era, there are some signatures, but only for the largest waterspouts that are relatively close to the radar. It's still very difficult to detect or anticipate waterspout development with NexRad. But we're hoping that with improved scan strategies, higher resolution, especially in the lower levels, and with the dual polarization upgrades, and I know my friends at Key West are looking at this, that these dual polarization upgrades might allow us to do a better job. But this was a case in which a waterspout was decaying, and you could see in the sun glint of the setting sun, the waterspout was actually, this is not a spiral pattern, this is a rain curtain because we flew through it. But the waterspout was actually, when it was decaying, the rain curtain was wrapping completely around the waterspout. And that's what you're seeing when you see a hook echo on a larger scale. But, that's what you see in tornadoes, the same kind of thing. Again, a couple of pair of dark spots. I think I showed you this slide earlier. One here. This is just west of Key West. And here's one of these dark spots. And again, the trailing wake. Don't understand how the mechanisms that account for that very persistent wake, even in this very weak circulation here. This is a dark spot. And then a few minutes later, this is what happens around the dark spot when you get a spray ring developing. And again, now you have a wake of a different structure, but still very persistent. Very persistent. There's Key West. They get waterspouts both north and south of the island there in the lower Keys, depending upon the low-level flow direction, whether it's east-southeast, east, or the most favorable direction appears to be right down the orientation of the islands when the winds are from the northeast at the lowest 10,000 feet. That same cloud line produced a series. Remember I said families are quite typical, especially in the dark spot stage. So you see one there, A second one here, there's a flare being drawn into the second one, another flare, another smoke flare there, another smoke flare there, and a spiral pattern here off to the right. Now you see the same case. In this case, the flare is being drawn in, the smoke plume is being drawn in to this third stage waterspout, the spray ring in the middle, and now you're getting the mature waterspout. In this case, the flare shows almost no effect, and shower in the background here. So again, I emphasize, these are concentrated vortices, and the flow patterns around them can be quite complicated, as shown by what you see there on the lower right. In 1993, I was asked by the National Geographic to organize an expedition to look for waterspouts in the Keys. They were putting together a TV special. It has aired a number of times on both PBS and NBC. It's on the whole variety of convective vortices, ranging from dust devils, waterspouts, tornadoes, up to hurricanes and typhoons. It's now in the video stores. It's called Cyclone. It's out on DVD now. It's called Cyclone. So you can see the waterspout segment. I won't have time to show it today, but originally we were supposed to be down in Key West for 2 weeks, and then at the last minute they told me we'd only have about 7 to 10 days. But fortunately, as almost always is the case, we picked the optimum time and we got good data. This is our best case. We had a pair of waterspouts that you see here, close together, fairly large. Again, like the twin tornadoes at Pilger just 2 days ago, although those tornadoes were much, much bigger and much more intense. Again, from the National Geographic expedition, this is a decaying waterspout, flare at the top, 2 more flares here, and the waterspout in this case is moving from left to right, and it was beginning to decay. And this is the same waterspout in the mature stage, very intense spray vortex, moving from lower left to upper right, and again you see this pronounced wave train. And again, I have to emphasize, these waterspouts, all of them, large and small, pose serious life-threatening hazards to boats of all sizes. And people continue taking chances in the Keys and elsewhere. Again, from the National Geographic expedition, a weakening spray vortex and this intriguing, persistent wake that you see here. To this day, I really don't have a good explanation. My hypothesis is that the wake is caused by the effervescence into dissolved CO2 bubbles that rise to the surface due to the rapid pressure drop in the core of the spray vortex, and that the wake is actually dissolved CO2 bubbles that are rising to the surface and that follow the center of the vortex. That's just an hypothesis. I'm sure there are others that one could advance. This is probably in the upper 5 to 10% of large destructive waterspouts. This was taken by an eyewitness looking southeast from Boca Chica. This is about as big and as bad as they get down there, and if one this size comes ashore, it will produce tornadic damage. This is about 100 meters, 300 feet across at the top, and again, you see these intriguing undulations on the funnel. But this is very, very dangerous when they get this large. Another dangerous event, and this one actually was a supercell spawned waterspout that tore through a yacht race that occurs yearly from Sydney, Australia to Tasmania. And you can see the setting sun there. The Aussie Bureau of Meteorology Doppler radar actually could see a mesocyclone in this storm from the shoreline, and it did a lot of damage. It capsized and demasted several of the yachts in the race. There were people that were tossed overboard, but fortunately only minor injuries. And again, waterspout families. Now, I'm going to mention later on the problem we have in our society with with Photoshop and what you can do to people that you don't like. You can put them in places that they've never been, and you can put heads on other people's bodies that weren't there. And there are other tricks you can do. But this photograph, I think, is real, and it's a rare case for sure, but not totally unheard of. Again, a waterspout family, all of them quite large and potentially destructive, in the Adriatic Sea off of Croatia. You see an island here. There are many islands just off the west coast of Croatia. And this looks like a line of probably, we're about to produce lightning and thunder, a line of thunderstorms. But all of these are mature waterspouts. And beautiful photograph. This was on the web. This is, I think, just 8 to 10 years ago. More recently, just a couple of years ago, August 18th, 2012, was taken by, I think, a storm chaser from Colorado State. And Weather Service people brought this to my attention. This was taken from a boat, from a ship, no, I think from the shoreline of Lake Michigan, looking to the east. And again, a family. 1, 2, 3, and a fourth, possibly a fourth one here. Certainly a fourth funnel, and possibly a small spray vortex right there. So there you have it, 4 waterspouts. Here's a close-up, beautiful shot. The waterspout on the left has a double-walled funnel. It's probably, I would say, moving from left to right. This one, the motion is not so obvious. This one actually may be moving toward the photographer from east to west. But again, spray vortex and the funnel. Another view, obviously this one is now in the decay stage. You see the shower beginning, the outflow from the shower beginning to hit it, and this one is still going. Perhaps one of the most beautiful waterspout photographs that I have, this was in Greece, one of the Greek islands in the wintertime, February 2000. And again, a mature waterspout here, possibly another one in the background. The photograph is a little bit grainy, but beautiful case. And again, look at the conditions there. Obviously, the surface winds are very, very light. They do get tornadic waterspouts in the Caribbean, I'm sorry, in the Mediterranean, and Cyprus has had a number of tornadic waterspouts come ashore. This was 2003 in January. There was an outbreak, a tornadic waterspout outbreak that made the news. There were apparently three waterspouts that came ashore. This was the largest and most destructive. Did a lot of damage in the downtown area of Limassol on the south coast of Cyprus. This came ashore moving from south to north. And I'd say that was a supercell case, no question about it, when you see the structure, the apparent cloud structure. Now, storm chasers will tell you to this day that if you're out chasing tornadoes, you got to be smart and you got to be lucky. Well, this was a fellow who's been doing it for many years. He lives in, a good friend of mine, Jim Leonard, lives in Miami, has a condominium. He was home from storm chasing, I think this was early summer, I think it was June actually, and he was taking time exposures at midnight. So he was trying to get, and did get, some very nice shots of the lightning. But much to his amazement, he also got a large waterspout, which was just 5 miles to his east. This was just offshore. And you could even see the spray here. So it was a very intense case. And again, this is at midnight, so this is time. This is a time exposure. Both of these are time exposures. There might be another funnel here, but a very large case, and it was actually moving. I looked at the radar, and the storm was gradually moving away from the coast toward the southeast. Very rare photograph. Do we get waterspouts at night in the Keys? Yes. I've talked to pilots, and especially on a moonlit night, the pilots that I talked to that had regular runs from Miami to Key West, they have seen them on occasion. Waterspouts occur in many diverse locations. We see them in Southern California, where most of my relatives live, and they are most common there in the fall and early winter when you get an upper cold low that drops in from the Gulf of Alaska, an upper cold low that cuts off the coast of Southern California. Destabilizes the air, makes the lapse rates become very unstable, which you have to have because the water temperatures here are so cold. At this time of the year, the water temperatures are at best 50s or lower 60s, at best. And this is a very large event that actually came ashore not far from the Reagan Ranch near Santa Barbara and did some, weakened, fortunately, but did some light damage on shore. It was moving, I think, from left to right. I've wondered, as I'm sure many of you know, there is a network of oil rigs off the Gulf Coast that stretches from Houston east of New Orleans. There are over 1,000 of these oil rigs, and I've wondered for years how often they see waterspouts. Well, my friends at the Houston Weather Service office sent me this series. I'm only going to show you a few of them, but this is a very large event in September 2002, and you can see they're watching it. It's moving away from them toward this platform over here, okay, but a very large event. And next picture in the sequence, it's beginning to move over this platform. I don't know if there were people on board that were on this platform at the time, but while it temporarily disrupts the circulation, the waterspout keeps going. And that's true of both waterspouts and tornadoes, by the way. Once they form, in the case of tornadoes, they can move across rivers, they can go down valleys and climb even some moderate mountains and continue. The key for both types of vortices is the near environment and the structure of the parent cloud. If you have the right conditions in the environment and a strong updraft in the parent cloud to sustain the vortex, it will continue over rough terrain. Very rare event. This is one of the tallest lakes in the country, Lake Tahoe, over 6,000 feet. Remember what I said about storm chasers. You got to be smart, you got to be lucky. Well, this fellow was a professional photographer who just happened to be out on his deck. He lives on the north shore of Lake Tahoe. He was out on his deck at 7 a.m. in the morning. That's another unusual aspect of this. 7 a.m. in the morning and saw what turned out to be an outbreak, a mini outbreak of waterspouts, about 7 of them. This was the largest that he photographed. Has a whole series of beautiful photographs of this event. And I wrote a paper on this in WeatherWise, about 10 years ago. And this was September 1998, and this was the largest of the waterspout outbreak. And again, this is in the WeatherWise article. Yes, there were some conditions that looked favorable, but I certainly wouldn't have forecast anything like that to occur. There's a little weak surface low. There's Lake Tahoe right there. And middle levels, low to middle levels, and upper low over the Central Valley of California to the west of Lake Tahoe. Some surface convergence and rising motion, but nothing really that would have highlighted anything to forecast a waterspout outbreak that morning. Now, landspouts. I don't like this term, and I've had arguments with good friends and colleagues like Howie Bluestein about landspouts. I think it gives a wrong connotation to the public. You could define a landspout as they also sometimes called gustnadoes. They're the weakest and shortest lived form of tornadoes, perhaps, but I don't like the term because it connotes to the public that they can ignore these, and they shouldn't. But here's some examples of weak tornadoes. This is near Cheyenne. Here's the surface vortex, and actually there was a very narrow funnel that went into the cloud base of the storm that was moving away up here. This is one of about 6 to 8 landspout events that occurred over the current site of the Denver airport. Ed Zipser and I wrote this up in Monthly Weather Review. This was in 1977, right over the site of DIA now. And of course, surprise, surprise, every summer now, this time of year, there are tornado warnings issued for DIA. And they occur so often that they've had to put up signs for designated tornado shelters, yellow signs in the concourses, which, by the way, are, as you know, the concourses there's glass everywhere. So wisely, they're directing people to go to the interior bathrooms for shelter when they hear the warnings. Another case from an aircraft. This is actually a pair of landspouts over Kansas. This was during a weather modification project. No seeding at the time. Now, for our friends that are online from Tampa Bay, you have the highest incidence of large destructive waterspouts in the country. This was a case that was also that I wrote up in Monthly Weather Review. Charlie Paxton knows about this, but this was one that touched down as a tornado over St. Petersburg. And this shows these dots are the track of the event, and actually it moved out over Tampa Bay and became a tornadic waterspout. And I'm not going to go into the details, but there were some mesoscale features that we think contributed to the development of this event. So can we forecast waterspouts? Yes. These are the kinds of things you want to look for. You want to look for boundaries, wind shift, or convergence lines. You're looking for rapidly building congestus lines. And why rapidly building? Because they have strong sustained updrafts. You've got to do mesoscale analysis. Most of the automated analyses will not pick up what you need. You really need to do it by hand, I think. LAPS is very helpful. That's a product that was developed by Global Systems Division here. And you need to look at the model soundings, but you need to look at the real soundings as well. The NexRad isn't going to help you very much, but hopefully with the dual pole upgrade and improved scanning strategies, you might get some help from NexRad. Waterspouts occur, again, in many different locations. And one of them in the late spring and summer is the Middle East Coast on Ocean City. This is Ocean City, Maryland. Anywhere on the mid-Atlantic coast, they get them, and they get them rather often, by the way, in the Outer Banks and North Carolina. I've had several reports from friends there. But this is one that came ashore in Ocean City and did some damage to condominiums. Now, what about the modern digital age? Can there be trickery? You bet there can be trickery, and there is. There are charlatans and fakes out there that use Photoshop and other ways of manipulating photography. And when I saw this, I said, well, it's not impossible, but several of us at the labs here, this was widely disseminated on the web as a waterspout outbreak on the edge of Hurricane Lily in October 2002. Well, guess what? The photographer at our labs here, Will von Dauster, pointed out to me that he thought this was a fake, and so he and I searched and we found the original, and it is a fake. The original actually just has the left of the 3 waterspouts. These other 2 were added with Photoshop. This is very recent. This is just, I think, the last year or 2. Kind of dangerous. This fellow was, I think, kite surfing. This is Grand Isle, Louisiana. And when you get a double-walled funnel like this, it's lethal. It's equivalent to a tornado at sea. This is, I think, very easily EF3, EF2, EF3. It'll do a lot of damage if it comes ashore, and it was obviously close to shore. And then finally, taking chances. This is during my field project, And I saw what I'm about to describe to you more than once, but this is the most blatant and dangerous example. You have a mature waterspout, very narrow funnel with the spray vortex here, and it's moving. There's the wake. So the waterspout is moving from right to left, okay? This was a fairly large outboard powered boat, chasing the waterspout. And as I circled and descended, worse yet, this outboard was towing a water skier. Chasing the waterspout, towing a water skier. Foolishness. This goes counter to everything we try to do in the National Weather Service when we issue warnings. And I have many other reports I don't have time to go into of people taking chances like this, and in some cases even worse than this, in the Keys and elsewhere. So I'm going to show you now some video. The first is from Singapore. This is to give you an idea of, especially for the larger waterspouts, how dangerous they can be. This was taken, a very rare video, one of the best I've seen. It actually shows a large waterspout over the Bay of Singapore, China. And you'll see, if you look on the left side, you'll see it spinning a freighter, a very large freighter.
And Joe, we'll put this on the website for those of you whose bandwidth you're unable to watch this with. We'll have a link to this video.
You can see the big freighter there spinning as the spout goes by it in the background. Show that one more time. Okay, watch right there. Okay, then I'm going to wrap up with some more video of my own. This is from the aircraft during my field project in 1969. You see a large spiral which is entering the third stage spray ring. If you look in the center of the spiral right there, and you'll see this spray ring beginning to spin up. There you see it right there. And this is a mature waterspout. And again, the velocity is near the center. Just focus your eye near the center. I know it's bumpy, but these can be quite intense. And remember what I said, even some of the smaller waterspouts can be quite intense and destructive, such as this one. There's some close-ups. You can see this turbulent cloud matter spiraling upward on the edge of the funnel there. And here you go. This is a fairly intense case. And now it's beginning to weaken, and there's a smoke flare that's being drawn into the circulation. Okay, this is a good place to stop, and I'll open it up for questions. And I hope you've seen the relationship now of waterspouts and the hierarchy of convective vortices that start with dust devils. My friend Pete Sinclair did his fine doctoral work. He was one of my heroes before I got into waterspouts. He did the key work on dust devils. He chased them using an instrumented jeep in Arizona. So dust devils, waterspouts, tornadoes, and finally hurricanes. These are all convective vortices. And we'll open it up for questions.
Thanks, Joe. Really appreciate that presentation. Learned a lot there. I've got two quick ones just to start off here from myself. How likely will a person encounter a waterspout compared to that of a tornado in their lifetime? So, I talk to a lot of folks, they've never seen a tornado in their life. Is it more likely, especially if they live along the coast, that they'll see a waterspout?
Well, I'll turn that question on its ear. What I tell people on cruise ships, or anybody, and I'm sure the Key West Chamber of Commerce doesn't want to hear me say this, but if you go to the Keys in the summer months from mid-May to mid-September, you have a much higher if you're there for a week or more, you have a much higher probability of seeing waterspouts than you do in chasing tornadoes and spending $2,000 or $3,000 to sign up for one of these companies. And I don't mean to disparage the commercial companies, because I think most of them are honest and do good work, but when you go with one of these tornado chase companies, you sign your life away, and that includes the fact that they don't guarantee you're going to see anything. So if you live on the coast, if you live in certain areas of the coast, if you live in Tampa Bay, if you live in anywhere in the Keys, and even in some places on the Great Lakes, much less frequently, but in the last 10 or 15 years, we've seen a lot more reports from the Great Lakes, both from the Canadian side and the U.S. side. So overall, your chances of finding waterspouts are much better than your chances of seeing tornadoes. But look at what some of these chasers are doing now just this week. I mean, on any given day, much to my amazement, there are scores of chasers out there. I mean, they're getting into traffic jams in some locations. Extremely dangerous. You better know what you're doing.
And you said May through September. Is there a maximum? Is there like June or July
yes.
where you would see more?
Andy Devanis has done a really much better job than I was able to do on going into that. There appears to be a double peak, I think one early in the summer in June, early July, and then another one later in the summer, late August or early September.
Now, you also mentioned the Mediterranean, and the examples you showed there seem to occur during the winter months. Is there a maximum there during the winter in the Mediterranean?
Apparently. But again, the data is, much less there, much less to go on. There, obviously the cases I showed were mainly winter, and I haven't had many reports of sightings in the summer months there, to be honest.
Okay, well, we're going to we got a lot of questions. We're going to try to buzz through here in the next 20 minutes. A lot of folks have written in already. Here's Ed writing, do waterspouts get as large and wide as land tornadoes?
Good question. The record was last year in Oklahoma, and I think that one was just about 2 miles wide. There's never been anything comparable to that size in waterspouts. The largest waterspouts that I've seen, tornadic or otherwise, are of the order of 100 to 200 meters across. Okay, whereas the largest tornado was, close to that record that was set last year in Oklahoma, 2 miles. But again, I leave the door open on that. We just need more observations. But again, waterspouts, dust devils, and tornadoes are in a hierarchy spectrum of both size and intensities, and there is overlap among the three. The most intense dust devils, in fact, can do damage. They've blown cars off the road. They've overturned mobile homes from dust devils. So, we keep getting surprises.
Stan writes in, wants to know if there's a Fujita or other scale used to classify waterspouts.
No. We use the same one that Fujita has that has now been used nationally by the Weather Service, but it only looks at damage. Remember that. It's just an assessment based on the damage produced by the vortex. So the EF scale applies equally to all windstorms. Okay? It's most commonly used for tornadoes and can be used for waterspouts that come ashore.
Here's a question from Stanton and one from Carl. They're very similar about the spots. the wondering on the dark spots, what are the size of them, and what is the minimum altitude for viewing? He says fish have been known to fall out of the sky too from some of these
Well, I'll touch on that one. I've spent a lifetime trying to nail down the issue of flying fish and waterspouts. All right, you get it all the time. You read about it in books, you hear it in the press, and I'll just say, if anybody has any documentation, especially photographs where you know the date and the time and the location of where the flying fish occur, and photographs showing the waterspout that was coincident with the flying fish, I want to see it, because I have yet to find any documented evidence. I've read a lot of stories about it. Now, the dark spots typically range from 5 meters across to the big ones can be maybe up to 50 meters across. All right, and that definition is the inner, to the outer dark patch. All right, not the inner disk, but the outer dark patch in size, from roughly 10 to 50 meters across. How low can you see them? I don't know. I mean, I've seen them from flying down below 500 feet, but I never wanted my pilot to get much lower than that.
Okay, Bill writes in, wants to know, is there much hailstone activity associated with waterspouts?
Not in the Keys, never. And when you get thunderstorms, generally the thunderstorms will occur coincident with the decay stage of the waterspout. And it's at that time that the heaviest rain is spreading out throughout the length of the cloud line. Once in a while, colleagues of mine like Jim Leonard or Jim Eds have taken video or photographs of waterspouts with lightning in the background. But what I would suggest is probably there was another part of the cloud line or a separate cloud line that was producing the lightning in the background. But it's rare to have lightning coincident with waterspouts, very rare. Usually it's as the waterspout is decaying or after it's decayed that the cell in the cloud line has reached thunderstorm proportions.
Joe, here's one, actually looks like a friend of yours. Ed Zoke from Boulder has a talk about the Boulder tornado that went over Baseline Lake in 1997. He sent a picture along with that.
Yeah.
And we'll try to get that up on the screen. Zach, I don't know if you can get that URL and just show that one. That would be neat to put up there.
Oh yeah, this is when we were on 30th and Marine Street, and Ed and several others were on the roof watching it. I'm familiar with that case. So they can occur anywhere. I have a case from Fujita, by the way, of waterspouts over an inland lake in Montana. So they can occur over any body of water, inland or coastal.
And Ruta from Maine wanted to know if they occur in Hawaii at all. Do they get waterspouts there?
Oh, yeah. Tom Schroeder there, my colleague at the University of Hawaii and the he's the director of the Jimar Institute. He's regularly sent me, and he's done studies himself of waterspouts in Hawaii. Yes, and I have a photograph of a very big one that was on the east coast of Oahu, and they actually had a very rare supercell waterspout just a couple of years ago. There were many photographs taken, and that same storm produced hail, which is extremely rare in Hawaii. So they do get waterspouts in all of the Hawaiian Islands, yes.
Joshua writes in and wants to know, what is the most damage ever done by a waterspout?
Oh, boy. Well, the short answer is I don't know. The worst that I've seen was is the one I touched on in my talk, early in my talk, the Dinner Key Boat Marina in Miami. There were many large yachts that were heavily damaged there in 1968. They have had damage in some of the islands in the Florida Keys, and I'll defer to my colleagues there at the Weather Service office, if they want to pursue that, if our questioner wants to write them. But I'd say the Miami Dinner Key case is the most destructive case that I'm aware, but I know that they also get a number of damaging cases in the Tampa Bay area. That's the first place I would look to do an assessment of damage from large waterspouts is Tampa Bay.
Okay, Michelle writes in, could a cruise ship be damaged by a waterspout? And since you're on these cruise ships giving these talks, it would be interesting.
Yeah. Well, yes. The short answer is yes. I have another case that I meant to write up but never got the time to do it because of some data gaps. But I had reports of a freighter, a very large freighter, that apparently was hit by a supercell waterspout, broadside, and it tossed some very large containers on that freighter around the decks and did some heavy damage to the ship between Taiwan and mainland China about 15 years ago. But it was, this was all there was no photography, so it was hard to be sure, what exactly happened. But it very likely was a supercell waterspout that hit this freighter. Well, and you saw from the video there in Singapore of what they can do, even to a large ship. I mean, it can spin it around, and it's no question there. So if you're on a cruise ship about to get hit, you want to get below decks, seriously. And I tell that to people in small boats. It isn't the wind that's going to hurt you or kill you. It's the flying debris, the mast or other loose objects on deck. You want to get low. You want to get, if you can't get below decks and you're about to get hit, I'd get my life vest on and get in the water and keep as low a profile as possible. The same kind of advice we give people, in tornadoes in the last-ditch effort. And then we have to kind of wrap up here in a minute.
Let's get another question or two. Jeffrey lives near Lake Superior. Does water temperature determine the strength or lifespan of a waterspout? And which lake in the Great Lakes seems to have more than others?
Well, I've seen waterspouts reported from all of them. Cleveland I've had multiple reports from Cleveland. So I would say Michigan and Superior, but I think they've been reported from all of the lakes. If you want to look up some more, if you want to delve into it, my colleague in Canada has published on Great Lakes waterspouts. He's done some really good work. The name is Wade Szilagyi, C-L-I-G-A-Y. Anyway, he's published on it on the Great Lakes cases.
Great. And since we got to go here shortly, let's just take one more here. And one of the questions was that here's a person this is Gary writing in, and he was on the beach. He noticed a waterspout came across, and then it hit the beach, dissipated quickly into nothing. Is it common once the waterspout hits land? And you mentioned they go as tornadoes, but what is the most common thing? Did they disappear?
The most common thing is that they weaken. Okay, but at the time you're there witnessing this, you can't be sure if this waterspout happens to be pendant from a supercell or a cloud system that's developing, into a supercell. The vortex can continue for a mile or even, can continue well inland or even cross the key as the one did at Matacumba. So when you're there at the time, you with limited information, I'd get out of the way and find a safe location away from debris or as low as you can, as low a profile as you can find for yourself, because real-time forecasting of these events when you're an eyewitness or in possible danger is extremely difficult. You don't have enough information to be sure.
And we just put up on the screen the Boulder tornado or waterspout there, photos by Ed Zoke. You can see that. Well, we really appreciate you taking the time. Folks, there's a bunch of other questions. We're going to send those. Hopefully, Joe, over time, will be able to email you guys back with some of the other answers.
Over the next 10 years, I'll email them back.
Okay. Well, hopefully he can get to that and answer those. And again, we thank you, Joe, for being with us today and taking the time to do that. We want to also let you guys know that there's a survey at the end of today's webinar. When you sign off, please take that survey. That'll pop up on your screen. And then please join us for our next CoCoRaHS Weather Talk webinar. That's on Thursday, July 24th. And this webinar will be on space weather, what it is and why you should care. It'll feature CoCoRaHS volunteer observer and the director of NOAA's Space Weather Prediction Testbed, Rodney Varick of NOAA's Space Weather Prediction Center, also in Boulder, Colorado. So thank you so much again, Joe, for being with us today. And until next time, this is Henry Regis for the rest of the CoCoRaHS team saying so long and have a great afternoon.